Welcome to the 2020 Math question 1I. The question asks, in the range x between minus 90 degrees and 90 degrees, how many values of x are there such that the infinite sum 1 over tan x plus 1 over tan x squared plus 1 over tan x cubed and so on is equal to tan x? Is it 0, 1, 2, 3 or 4 values of x? Pause the video and have a go at doing this for yourself. Okay, let's start by calling this infinite sum S. And what can we notice about the form of this infinite sum? Well, this is a geometric sum, so let's just recall what that is and how we can evaluate them. So a geometric sum is a sum of the form a plus a times r squared and so on, where we're multiplying the terms of our sum by a common ratio, r, each time. And this is equal to a over 1 minus r, but it converges if and only if the absolute value of r is strictly less than 1. And if that isn't true, then it will diverge to infinity. So since we're trying to see when this sum is equal to tan x, we need it to not diverge. So we're going to need to make sure that our ratio has an absolute value strictly less than 1. And we can actually evaluate this sum, therefore, if we can identify what a and r are. So let's look at our sum. A is going to be the first term of the sum, so that's just 1 over tan x. And then what's the ratio that we're multiplying our terms by each time? Well, to get from 1 over tan x to 1 over tan x squared, we're multiplying by 1 over tan x. So our ratio r is 1 over tan x. And therefore we can evaluate s in this form as 1 over tan x divided by 1 minus 1 over tan x. And if we multiply the top and the bottoms of the fraction by tan x, then we can see that this is just equal to 1 over tan x minus 1. But this is true if and only if the absolute value of r, which is 1 over tan x, is strictly less than 1. And we can see that that's exactly the same as if the modulus of tan x is strictly greater than 1, if we multiply both sides by the absolute value of tan x. So we therefore want to solve when this sum s, which is equal to 1 over tan x minus 1, is equal to tan x, in the case that the absolute value of tan x is strictly greater than 1. And our task is to find the number of solutions to that problem. So now that we've rephrased the problem, have a go at pausing the video and doing this for yourself.
Remembering that x needs to be in the range from minus 90 degrees to 90 degrees. Okay, well let's begin by multiplying both sides of this equation by tan x minus 1 to get rid of this fraction. And that's totally valid to do because we know that the absolute value of tan x is greater than 1. So this tan x minus 1 term can't be equal to 0. So when we multiply both sides by that, we get 1 equals tan squared x minus tan x. And now let's move the 1 onto the other side, so we just have a quadratic equation in tan x. And now using the quadratic formula, we can solve this to see that tan x must be equal to 1 plus or minus the square root of 5 over 2. So we now have the value that tan x must equal, if the equation is satisfied, with the constraint that the absolute value of tan x needs to be strictly greater than 1. So now we just need to work out how many values of x in the range of minus 90 degrees to 90 degrees satisfy this, and indeed if there's any contradiction between these two statements. So let's move on to a new page and try to do that. Okay, so here's the problem we need to find the number of solutions to. Now, what could the contradictions be between these two statements? Well, if the absolute value of 1 plus root 5 over 2 or 1 minus root 5 over 2 is not strictly greater than 1, then that means that we'll have a contradiction here, and that will tell us that actually tan x can't equal one of these values. So how can we try to find the absolute value of 1 plus root 5 over 2 and 1 minus root 5 over 2? Well, root 5 is a difficult number to deal with, so we can try and bound it with some more easy numbers. And how can we do that? Well, we can start off by thinking about where 5 fits in between square numbers, and indeed it fits in between 4 and 9 if we list out the square numbers. So if we square root everything here, that tells us that the square root of 5 is between 2 and 3. So now, using these two inequalities here, we can establish a lower bound for 1 plus square root 5 over 2, because that's going to be greater than 1 plus 2 over 2, which is equal to 3 over 2, which is 1.5, so that's strictly greater than 1. So that tells us that the absolute value of this is strictly greater than 1, so that's okay. But now if we look at 1 minus square root 5 over 2, we can find a upper bound for that by using 2. So that's going to be strictly less than 1 minus 2 over 2, which is equal to minus a half. But we can also find a lower bound for it, because that's going to be strictly greater than 1 minus 3 over 2, which is equal to minus 1. So we can see that 1 minus square root 5 over 2 lies somewhere between minus 1 and minus a half, and that means that its absolute value is actually less than 1. So we therefore can deduce these two things, and that tells us that we cannot have tan x equal 1 minus the square root of 5 over 2, because we know that the absolute value of tan x needs to be strictly greater than 1. So therefore we only have solutions when tan x is equal to 1 plus the square root of 5 over 2. So our task now is to find how many values of x in the range from minus 90 degrees to 90 degrees are there such that tan x is equal to 1 plus square root of 5 over 2. So in order to do that, let's draw a sketch of tan x from minus 90 degrees to 90 degrees, and that looks something like this. And we can see it's a one-to-one function, so therefore if we draw in the line at 1 plus square root of 5 over 2, we can see there's just one intercept between these, and that corresponds to there being one solution to this equation in the range x from minus 90 degrees to 90 degrees. So if we look back at our multiple choice answers, that tells us that the solution is B, with one solution to the equation. So we are done with this question.